Find the minimum and maximum values of x squared plus y squared, where x squared plus xy plus y squared equals 19. The problem is to find the maximum and minimum of x squared plus y squared subject to x squared plus xy plus y squared equals 19. We can use the Lagrange multiplier method, which involves solving a system of equations. This process might be computationally intensive. We'll use a simpler approach by converting the problem and writing it in polar coordinates. Let x equal r cosine theta, y equal r sine theta. Equation 1 can be written as r squared cosine squared theta plus r cosine theta r sine theta plus r squared sine squared theta equals 19, which can be written as r squared times cosine squared theta plus sine squared theta plus sine theta cosine theta equals 19. Pythagorean identity: sine squared a plus cosine squared a equals 1. So cosine squared theta plus sine squared theta equals 1. Double angle formula: sine 2a equals 2 sine a cosine a. So sine theta cosine theta equals a half sine 2 theta. So we can now write r squared times 1 plus a half sine 2 theta equals 19. X squared plus y squared equals r squared equals 19 over 1 plus a half sine 2 theta. Since minus 1 is less than or equal to sine 2 theta is less than or equal to 1, so x squared plus y squared is minimum when sine 2 theta equals 1 and is maximum when sine 2 theta equals minus 1. So the minimum of x squared plus y squared equals 19 over 1 plus a half times 1 equals 38 over 3. The maximum of x squared plus y squared equals 19 over 1 plus a half times minus 1 equals 38. Additional problem: find the minimum and maximum points x, y of x squared plus y squared, where x squared plus xy plus y squared equals 19. Thank you for watching. Hope you found this video helpful. Please subscribe to this YouTube channel for notification of new videos. See you next time.